Okay, but we're not done, people, because here's what happens. We have now finished this block of code, right? We finished average grades. We saw this return keyword, and the return keyword says, hey, I'm done with this execution context. I'm out. I'm done with it. So this is also what happens next. When we get to the bottom of that block of code, when we hit that return keyword and we're telling JavaScript, hey, we're done with this execution context, in that moment, a couple things happens. One, remember how I told you we pushed the call frame onto the call stack? When you add a call frame to a call stack, we call that pushing. When we take a call frame off of the call stack, we call that popping. Pushing, popping, pushing, popping. So we're going to pop the call frame off of the call stack. So now, average grade, you're done. We're done with you. And what this is telling JavaScript is, hey, get back into the global execution context. In addition, we also get rid of our local execution context. This goes bye-bye. When we finish our function, while running our function specifically, our local execution context is gone. We're no longer in average grades. And now we go to the next line of code. And Asar, what line of code is that?
The one below constant, line 8.
Yep, and walk me through it.
So we're declaring a variable with the keyword const. The variable is new output.
Yep.
And then we're assigning it the average grade function, which we're invoking.
Yep. And where are we saving new output?
We're saving it in the global memory.
Yep. And again, while we go now, we're going to go invoke and we're going to go run average grade. But in the meantime, what is new output equal to?
75. No, oh no, it's new output's equal to
undefined.
But
good, but exactly, right? In the meantime, it's equal to undefined.
Oh, is that because you erased everything? I mean, in the global execution context? All right.
So the reason it's undefined is until we actually get a value back from our function, in memory, it will be undefined. Undefined is a value in coding. I know that's kind of a weird thought, like undefined, but yeah, undefined is a value. It just means not defined, right? So until it gets defined, meaning until it gets some kind of value, its value is undefined. So while we wait to run the code, it's going to be undefined, the value stored there. Kanwar, I see you have a question.
Yeah, so when you said you made, so I want to go back to output. So before, like when you define that this is a function call, it's considered undefined, right? And then it was pushed into the call stack. And then I remember we got it hit return. And then when it gets that return, does that pop it off and then it goes back?
So when we invoke the function that pushes it onto the call stack, when we hit that return, it pops it off of the call stack.
Okay, all right, that was it.
Awesome. Good question. Okay. Let's see. Just trying to go through the chat. Just a heads up, people, I'm not going to very often be looking at the chat, so it would be easier to either raise your hand with the raise hand feature or unmute yourself, but I'll try to check out here. When you are defining the function, should it end with a return statement? So that's the question, right? So we have this return statement. Let me tell you this, people. I'll tell you right now. If we wrote any code inside of the body of that function after the return statement, JavaScript wouldn't even look at it. The moment JavaScript gets to the line that says return, it's done. It's out. But I will say, I don't want to confuse anyone, but I will say, let's say, here, let me actually use white. Let's say we never even wrote a return statement. Let's say this last line didn't even exist. You might be thinking, well, how does it know to ever get out of this execution context? Like there's no return keyword. How does JavaScript know it's done? I will say at the bottom of every execution of every function, there's basically like an invisible return here, whether it's written or not. The idea is once JavaScript gets to that final curly brace, if it hasn't hit a return statement yet, it'll just return. It'll just pop out and return nothing. And by nothing, I mean it will return undefined. But my point being, the return statement tells JavaScript you're done. If there was code below the return statement, it wouldn't even get to that. But if you never wrote a return statement, when you get to the final curly brace of your function body, then JavaScript's going to go, okay, like we're at the end of it, so I guess I'll just return, you know. So also, regardless of const or let, all things are going to be stored in the memory of which the current execution context you're in. So for example, if we had said let output equal average grade, like if this had said let, regardless, the same process would happen either way. Just a heads up. It's not like declaring it with let or const changes the process. It just changes whether or not you can later change the value, what's stored there. Is it Elisa?
Yes, that's correct.
Okay. Awesome.
So my question is, if we had not included the return average statement at the end of the function,
Yep.
then output would have continued to be undefined at the end when it was popped off the call stack.
What a phenomenal question. So yes, this is kind of honestly my next slide. But Elise is asking this, right? So let's kind of backtrack for one moment. So do we remember how it was undefined here, right? Until we hit that return statement. And then it returned average. Average was 75. So what was undefined became 75. If we never had that return statement at the end, it would stay undefined. We never told it what to return, right? So we need to be cognizant when we're writing our functions that whatever we write for our return statements, whatever we write after that, that's the value that gets returned. If we don't write one, then the function will stay undefined. Nothing will get returned from it. So we'll kind of actually see this because we have kind of some examples around that idea. But excellent question. Yeah, so the fact that we have that return statement that says return average, that's why we get the 75. If we didn't have that last line there, output would stay undefined. Okay. Yes, Asar.
Just two really, really quick questions.
No,
How do we, just like clarification on the call stack. So call stack, is it just basically just tells us where we are just in relation to like whether it's a global execution context or global memory and local? Is that basically what it is?
Exactly.
Okay. And second question, you mentioned this before, but I missed it. When we were in global context and we were invoking the function, how did JavaScript know to go into the body of the function?
Good question. So the parentheses next to it on the final two lines there, the parentheses at the end tell it go. So what it does is it will look in memory and we'll go, okay, there's this average grade. Is there an average grade in memory? There is. I have stored the function definition there, so I will now enter the body of that function.
Gotcha.
Cool?
Cool. Yeah.
All
Thanks.
right, so excellent. Okay, so actually let's keep going. So while I still got you, and let me erase the portion I crossed off. So, okay, Asar, so we set new output until we get a value returned, it's undefined, right? What are the immediate two things that happen now that we have invoked average grade on this final line now? We get two things. We get a what?
We see two parentheses.
Yes, but when we no, that's a good guess. Yeah. When we invoke it, we get a new.
We get a new so we're adding to the call stack.
Yes. Okay.
Yeah.
So good. So remember, pop is to take it off. Do you remember what it is to put it on?
No, I don't remember, but
I'll give you a hint.
Oh, push.
Push. Excellent.
Push.
So we push a call frame onto the call stack called average grade. All right. Cool. That's one. What's the second thing we now also get? We get a new or a
new It's a new.
I'll give you a hint. I'll give you a
Yeah.
hint. It's inside of here.
Oh, it's what is it? A new local environment, like a new local
Yep.
execution context?
Exactly. We get a local execution context. Well said. Well said. So we get a local execution context.
And how do we know it's local though? Like, how does JavaScript know that it's local?
Because right now, if you can imagine, JavaScript this is like here. So this area here and these lines, this is the global space. This is the most outer layer you can go.
Uh-huh.
But when we invoke a function, JavaScript now enters this line, like this body, this function body.
Mm-hmm.
When it enters that function body, it creates a local execution context. That's just how it works. And let me tell you this, I don't want to get, again, too advanced, but if you called another function inside of that function, you'll have a local execution context inside a local execution context, now inside the global execution context. We got a little inception-y. Literally, that is the idea of recursion. Gustavo, I see you. What's up?
Yes. Now, what will be the best or easiest way to remember this function, so this sequence where everything is being stored, or the memory where everything goes and the sequence that it goes?
So again, the way we remember this is we just think the way JavaScript would. So, right, when we declare a function, we save that in global memory, if that's the execution context we're in, and we'll always know where we're storing things because of our call stack, right? We'll always know, are we in global memory at the moment? No, we're in the average grade. So we know everything now inside of average grade. All of this will be stored in local memory inside of this local execution context. All right, local memory. But if we were in the global execution context, then everything would be stored in the global memory. So it's really, where are you on the call stack? That kind of helps you see where are we storing things.
Well, more my question is like the process, how everything goes. How important it is to remember, where you, I know it's important to remember where you're at, but I mean, the sectors, the call stack, the global execution, where everything is going. When you're writing, like, for example, when I'm writing in Python, it's just like automatically I'm writing it, but to remember where everything is going, like,
listen, when you write code and you inevitably get stuck, you're going to go, how do I unstuck myself? How do I debug? This is how you debug. You're going to break it down the same way JavaScript would and think the way JavaScript does, and therefore you'll find it easier to work through the problems you have.
Thank you.
Yeah. All right. We're going to keep it going. So Asar, we now have our local execution context. We have our local memory. We've pushed a call frame onto the call stack. We now enter the actual body of the function. Walk me through the first line inside of that body.
Okay, so first line, we're declaring a new variable, my grades, with the const keyword. Yep. And then we're assigning it an array with 3 indexes. First one is, well, at index 0, it's 50. At index 1, it's 75. And index 2 is 100.
Excellent. And so let me ask you, where are we saving that?
We're saving that in the local memory. Or we're saving it, yeah. We're saving it in my grades, which is in local memory. Yeah.
Exactly, yes. Okay, keep it going.
Okay, now next line, we're declaring a new variable sum with the let keyword, and then we're assigning it a value of 0.
And every time, so where are we saving it?
Local memory.
Yeah. All right, keep it going.
Okay, we're reassigning sum, a value of basically the sum of all the elements in the migrades array.
Walk me through it.
So okay, so we're reassigning sum, and then we're saying it equals the element at migrades, the element at index 0 of migrades, which is 50.
Yep.
And then we're adding that to the element at index 1 of migrades, which is 75. And then we're finally adding it to the element at the value at index 2 of migrades, which is 100.
Excellent. So sum is equal to 225. So let's change that here. Sum is equal to 225. All right, keep it going.
Okay, and now we're declaring a new variable called average, and we're assigning it basically the value of sum, which is now 225, divided by the value of the array, the value of the array migrades, the length property of the array migrades, which is equal to 3.
Excellent.
So yeah.
And where are we storing average?
We're storing average in local memory.
Excellent. So average equals 75, right? Because 225 by 3 is 75. Okay, next keyword, or next line.
Next line is, we have the return keyword, and we're basically now returning the value of average, which is 75. We're returning it to the I guess the global execution context, or what do we returning it to?
You could say we're returning it to global memory, and you can also say specifically what. Where is it being returned to? What variable?
Oh, it's being returned to, what is it? New output?
New output. Excellent. All right. Well done. But we're not done yet. What happens next now that we've returned and we've kind of hit that final line?
So now we're popping average grade off the call stack.
Excellent. And one last thing, what does that also mean?
That means that all the variables that we had defined and declared in the body are now like erased. All the local execution context and local memories all
exactly.
Put.
We finish our local execution context. Excellent job. Okay, guys. All right, so we have gone through. Thank you so much. I really appreciate that, Asar. So we have gone through our first function. We did it. We did it. We got through the function. We got through the function twice, 2 times. Okay, that's great. But people, this is the return keyword that I talked about. Okay. If we did this. Okay, people, here's the problem with this function, right? Here's the problem with average grade as it's set up. It's kind of a lame function, right? I mean, all it does is return the average of 50 plus 75 plus 100. That's it, which is 75. Every time I would invoke this function, it would return 75. I mean, it's not even really average grade. It's the average grade if your grades were 50, 75, and 100. Right? Like, not very dynamic. Kind of lame, to be honest. So how can we make this more dynamic? How can we make this actually work so we can get some average grades based on, if I had 3 grades, if, Carlos had 3 grades, Tyler has 3 different grades. How can we get a function that'll actually find the average of people and their 3 different grades? Well, it was mentioned a little bit earlier, but I'm going to dive into it. We can utilize something called parameters. So do you remember earlier I said, we have our function keyword, we have our average grade, and then there's these parentheses right next to average grade. I'll show you right here, right here. This parentheses right here And I was like, don't really worry about it right now. Well, now is the time to worry about it. So now what we put inside of there is called parameters. Parameters are just like variables in a way. They're just ways to store information. And the idea is this. We have this variable or this parameter called myGrades that we've now put right inside of this parentheses. I want to show you that now when we invoke average grade, things should look relatively similar. There's some differences, but relatively similar. But now when we invoke average grade, do you notice that we're not just passing in nothing? There's not like it's an empty parentheses when we invoke it. We actually now have some information. And now our function will take this information. This information is called an argument. So parameter is right here. This is the label for if you want to pass information in. Argument is the name of the information, the data you actually do pass in. Argument, and we have our parameter. Parameter is the label, argument is the actual data you pass in. So we can now pass in an array of 3 grades, 50, 75, and 100. We can now pass in an array of 3 other grades, 100, 85, and 100. And we're going to dive into this, but now we have a function that maybe, just maybe, people will give us the average grade of any 3 grades. We'll see, maybe. All right, let's do it. So everything else is still the same, right? We still have our call stack global execution context. Let me actually set that up. Okay. Carlos, we're on line 1. Let's do
All
it.
right, let's do this. So we'll be declaring a function, average grades, and we'll be storing the function definition of that in global memory.
Excellent. So average grade, is equal to the function definition. Okay, and then let me ask you, Carlos, do we now go inside the body of the function?
We do not. JavaScript will just ignore it, store definition, and continue forward.
Okay, so what's the next line we're at now?
Sure, I believe that's line 8. We'll be declaring a constant variable, label it as output, and we'll be assigning to it the evaluated result of invoking the average grade function with the arguments of 50, 75, and 100, which is an array.
Exactly. And where are we storing output?
Output would be stored in global memory.
And what would it be in the meantime while we wait?
While we wait, it would be undefined.
Excellent. Okay. All right. So now, Carlos.
What's up?
We've invoked it. What are the things that now happen? We have a couple new things going on here. We get a new what and a new what?
So first we'll be pushing on to the call stack, the average grades call frame.
Yep. Okay.
And we'll be creating a local execution context and local memory.
Excellent. Local execution context, as well as a local memory. All right. Okay. So now, what is the next thing that happens, Carlos?
It's actually a new step. We'll be first passing the arguments into the parameters of my grades. So in local memory, we'll be storing my grades as the array of 50, 75, and 100.
Okay, so Carlos is spot on. We do what's called handling your parameters. We always handle our parameters. So, earlier we had nothing in those parentheses. We didn't have to handle any parameters, but now we got a parameter. We got a parameter called myGrades. And so we handle this like this. It's kind of like the same thing as handling any other variable. In local memory, we will now take myGrades, right, which is this parameter right at the top here, myGrades, and it is equal to whatever argument we passed in. And what did we pass in as an argument? As Carlos mentioned, it was an array of 50, 75, and 100. We've handled our parameter. Our parameter was myGrades. That's the first thing we do. and our parameter is my grades, and we set it equal to the argument we pass in, which, if you see right here, is an array of 50, 75, and 100. Excellent. All right, so keep it going, Carlos.
All right, so now we'll actually dive into the function itself. So
Yep.
we're on line 2, and we'll be declaring a variable labeled as sum and assigning it the value of 0.
And where do we save that?
It will be storing that in local memory.
Excellent. Sum is equal to 0. Okay, keep it going.
All right, line 3, we're going to assign to sum the evaluated result of adding my grades at index 0 plus my grades at index 1 and 2 together. Yep. So that would be 50 plus 75 plus 100, which is 225. And
Great.
we'll reassign that in local memory.
Excellent. Keep it going.
We're declaring a new variable labeled as average, and we'll be assigning that the evaluated result of dividing sum by my grades at length, which would be 25 divided by 3, which is 75. And that would then be in local memory.
Okay, last line.
And last line, fun keyword of the day, return. We'll be returning the value stored in average, and that would be returned to output in global memory.
Excellent. So now this is 75. And then what happens next, Carlos, now that we've kind of wrapped that up?
Yep, we'll finally pop off average grade off the call stack, and we'll garbage collect our local execution context and memory.
Excellent. Excellent. Wow. Very well technically communicated. Well done, Carlos.
Thank you.
All right, people. So Carlos said it very eloquently. And also for those that didn't, he said garbage collected. You might be like, garbage collected, what does that mean? So just so everyone's aware, under the hood in JavaScript, when you delete any variable or you kind of remove anything, there's a process called garbage collection, which is under the hood. JavaScript has a process of kind of removing things from memory. We're not going to go into that. It's very in-depth, but that is the idea. Garbage collects it, gets rid of its garbage. Okay. So now you might be thinking to yourself, this was fun and interesting, but we got the same value. But do we recognize, honestly, let's keep it, even before it, let's keep it going. Honestly, let's keep it going. So Christelle, we're on the final line here. Walk me through it.
Okay. We're going to declare a constant variables assigned to new output.
Yep. And where are we storing that?
In the global memory.
And what is it equal to when we first invoke this function?
Undefined.
Excellent. Okay, what happens next?
All right, we're going to put average grade. We're going to push it to the call stack.
Excellent. Okay.
And then we're going to create a local execution context. We're going to have a local memory.
All excellently said. Local memory and local execution context. So now, what's the first thing we do?
We're going to pass the array of 100, 85, and 100 to my grades.
Okay, and where are we going to store that?
To the local memory.
Excellent. So we're going to handle our parameters. So my grades is going to equal an array of 100, 85, and 100. Okay, what's next?
We're going to declare a sum variable, and we're going to assign it to 0.
And where is that?
Local execution context.
And specifically, where do we save it?
To the local memory.
Excellent. All right, next line.
All right, we're gonna have some variable which is equals to my grades at index 0, which is 100, plus 85, which is index 1, plus 100, and index 2. So the total is 285.
Excellent.
And then we're gonna declare a variable which is average. And we're gonna have the sum, which is 285 divided by my grades.length, which is 3. And the total of that is 95, I believe.
Excellent. Yep, 95. And where do we store that?
To the local memory of average. And then we're gonna return it to the global memory, which is our new output.
So, yep, exactly. So we're going to put it here. So then this becomes 95. And then what happens next?
We pop it off the call stack.
Yep.
And then we garbage collect.
Exactly. Exactly. That is exactly what happens. And now, look at this. Thank you, by the way, so much. So well said, Christelle.
Thank you.
So look at this. Guys, we now have a function that can take any 3 numbers and return the average for us. This is way better than the last function I showed you guys, which all it did, right? All this does, not this one, this one. All this does is give you 75 over and over again. All it does is give you the average of 50, 75, and 100. Now we have this function that will give you the average of any 3 numbers. This right here, though it's simple, is the power of functions. The fact that you can put dynamic data and get dynamic results. And by dynamic, I mean you can put different data and therefore get different results. This is some really powerful stuff. Okay, so this is good, much better than last time. Let's keep it going. All right, we're gonna learn about console log. Some of you may be familiar with this. The console is just like where code shows up when you wanna actually see, right? Because JavaScript runs code that we don't see. It does it under the hood. But if we actually wanna see the results of some things, we need a console log. That console log is just a function built into JavaScript that will take whatever you write inside of the console log and put it onto our console. Again, the console is just the area of the screen that we can see in terms of like where code will show up when we console log things. So let's do it. All right. So I want everyone to notice it's pretty much the same thing, but I've added this extra part here called console. This is different. This is, imagine like if you've been to like CSX or any Codecademy, like when you click run code and then like you see things show up in your console, this is the console. Okay. So let's hop into this. So Sanaya.
Yes. So we're going to start with line 1. We're going to declare a function called addFunc. Store that in the global memory as the entire function definition.
Excellent job. Keep it going.
Then we're going to declare a constant variable called output and invoke our addFunc function and set that in the global memory to undefined for now.
Excellent. So when we invoke a function, what happens?
So we first add our addFunc execution context to our call stack. And then we create a local execution context with a local memory and our thread of execution.
Hey, thread, there you go. Local memory, local execution context. Just as a little dive in, Sanaya made an excellent technically communicated an excellent point called the thread. The thread is the same thing as saying where JavaScript currently is. So the thread of execution is saying our thread is currently inside of this addFunc. How do we know that? Because that's what's at the top of our call stack, and we're in our local execution context. It's just another way of saying where is JavaScript? It's the same things. That's what thread means. Okay, what is next, Sanaya?
So next we're going to pair our parameter with our argument. So we're going to have num1, num2 equal to 50, 75.
And people, just so you're aware, you might be thinking to yourself, well, how do we know that 50 is going to go to num1, 75 is going to go to num2? It's as easy as the fact that num1 is the first parameter and 50 is the first argument. Num2 is the second parameter and 75 is the second argument. That's really all there is to that. All right, so keep it going. We've handled our parameters.
So next we're going to go into the body of the function, and we're going to console log 50 plus 75, which will equal to 125.
Exactly. So Sanaya, let me ask you this. So console.log is a function. So just to be very clear, I just want to make it clear that we will be adding it to the call stack.
Oh yeah.
But I will not be creating a new execution context. The reason being, for people that are aware, is console.log is actually, I don't want to get too in depth, but console.log is actually a function that's kind of a little bit separate than JavaScript. It works with JavaScript, but it's not purely JavaScript. It doesn't create a new execution context, but we do add it to the call stack. All right, so we're going to console log num1 plus num2. So imagine this is our console. So on your screen, on your console, what would pop up? It would pop up 125. Okay. Okay, Sanaya, let's go to, okay, so firstly, let's do this. We finish our console log. What happens after we finish our console log?
We garbage collect our execution context.
Exactly, and we also do what?
And we pop it off the call stack.
We pop console log, and we also pop what off?
Our add func function.
Exactly. Okay, so go to the next line.
Then the next line is console.log output. So that will just log, that will create another console log on the call stack, and then it will log 125 on our log.
Okay, let me ask you, Sanaya, are you positive about that? Let's go think the same way that JavaScript would. If you were to console log output, JavaScript would go look in memory for output, and what would it find at output, Sanaya?
Oh, it will go to the global memory to find output.
And what would it console log?
And it would console log. Wouldn't it console log 125, or would it console log undefined?
Well, let me ask you this. What is the value stored at output?
The value stored at output is our add func function. So and we'd have to invoke that function once again.
Okay. So, excellent guess. Do you remember earlier, Sanaya, I mentioned that if there's no return keyword at the bottom, right? If there's no return keyword in our function, what does it return?
Undefined.
Yeah. So output was equal to undefined. And you, by the way, when you went through the body, when you went through the steps of add func, entered the body, created the new call stack, you did it all great. And you did it perfectly. And let me ask you, did we ever change output to 125?
No, we never did.
We never did. We console logged num1 plus num2. Okay, we logged to our console 125. Did we ever return num1 plus num2?
We never did. So console would log output as undefined because we never returned it.
Exactly. Literally, this is what our console would look like. It would show 125 and then undefined. This is why the return keyword is so vital. Console log is not a return word. Console log just says log this to the console. Make it so that I can see. But it doesn't change its definition, its value in memory. The return keyword can do that if we're talking about functions, right? So excellent job, Sanaya, noticing that because we never said return num1 plus num2, we never changed the definition of output in memory. So this is exactly what would be logged. Also, let me get rid of this. Okay, we're moving forward. All right, people, we're going to talk about objects. So objects are awesome. Objects and arrays have actually a lot in common in that they both are data types that can store information inside of them. And we're going to kind of dive into what that means more specifically. First, I'm going to have a sip of water. One sec. Okay. Get my backup water. So, objects are like arrays, data types that store information inside of them. Arrays, we declare with those brackets, right? We know with arrays, there's a bracket around them. Arrays have brackets. You know, we had 50, 75, 100. Objects are declared a little differently. Objects are declared with curly braces. Curly braces. So when you declare an object, it has an opening curly brace and a closing curly brace. Additionally, objects have what's called key value pairs. Key value pairs. Let's kind of look at this. So here we have an object called person. The key is the value on the left of the colon. It is technically a string. A string just means a line of text. In a way, you can kind of actually envision it also having quotes here. Things that are variables or words that are in quotes are called strings. Strings is a data type. It means text. So keys are basically strings, and to the right of the colon is its value. So you could say this as like, okay, we have this person object. It has a key of name and a value of a string will. Key value pairs are separated by commas. Commas separate key value pairs. Colons separate keys from values. Commas separate key value pairs. Okay? So you could just get information, right? Name, will, company, a string of Codesmith. His fave num is the number 17. Has red hair is the Boolean true. And here's the even cool, same thing. So arrays, you can store data inside of it. You could store an array inside of an array. You could store an object inside of an array inside of an array. You could totally nest those things. It's the same thing here. With an object, you could have a key and a value that's an array, and that array has values inside of it. The string twin snakes, this string gummy bears. So we'll kind of dive into this. So what would this look like in memory? Okay. We don't need to do any execution context anymore. We're done with functions. We're going to talk about objects. But we do need our global memory. That we do need. So we'll just put global memory. And global memory would have a person, right? We're declaring an object. It would be equal to an object. And this object would have a bunch of key values. And what would those be? Name, will, company, Codesmith, fave num, 17, has red hair, is true, fave snacks is an array with the string twin snakes, which must be some kind of like British gummy thing, I guess, and gummy bears. Okay. So again, objects are just information. We declare objects with curly braces. They consist of key value pairs. Keys are just, I guess another way you could kind of think of it as labels themselves, really. I mean, like variables, parameters, keys, they're all just labels. To the right of the colon is the value. It's, in a way, you can kind of think of this as saying like name equals will, right? Company equals Codesmith. Okay. Also, by the way, if you were unfamiliar in JavaScript, we do what's called camel casing when we declare a variable. So like you see how like fave num, the F is lowercase, but the N is capitalized, or has red hair. So basically the first letter is always lowercase, but after that, the first letter of the next word in your variable name. So for example, red and then hair, the R and the H, those become capitalized. It's just like a reading convention. Okay, so we have this object, it's storing information. But what's really important is how do we access that? And there are a couple ways we can access this information. The most common way is called dot notation. Dot notation. And you can see that on this line right here. So when we write something like person.name, this is what JavaScript does. When we write person.name, it sees this dot. It looks to the left of the dot. And it goes, I'm going to look in memory to see if there's something in memory stored at the variable to the left of this dot, which for us is person. And it goes, let me look in memory, blah, 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 blah. Ah, here we go. Here's this person, and it's an object. Now let me go to the right of the dot. What is this? And it will look inside of this object and see, is there a key of name? And there is, right? Right here. And what is the value at that key? It's the string will. So for example, if we were to console log person.name on our console, so for example, let's do this. We had a console. If we console person.name, our console would show will. It would show the value stored there. That's one way, dot notation. You look to the, JavaScript looks to the left of the dot, says, is there some, likely an object stored in memory with a name to the left of the dot? If there is, then go look inside of that object if there's a key of the value that's to the right of the dot and return the value stored there. Another way you can do it is called bracket notation. So if we were to console log person bracket the string fave num, when you have a bracket and then a string inside of it, what JavaScript will do is it'll say, first, let me look to the left of the bracket and see, is there anything in memory called person? Great, there's an object. When you have a bracket with a string is a data that's wrapped in single quotes, double quotes. So these are all the same way. These all are the same thing. Fave num. Fave num. There's also backticks. I don't know where it's on a Windows machine, but on a Mac, if you look to the topmost left of your keyboard where the tilde is, there's a backtick symbol. That also works. So backtick, fave num. Above the tab, yes. So, also, I guess also maybe on a Windows computer. Okay, got it. So above the tab is exactly where you can find the backtick. All three of those work as ways to declare the equivalent of what's called a string, the idea of it just text. Okay, So when you write code like this to try to find some value in a key value pair inside of an object, JavaScript will go, okay, person, let me look and see if there's a person object. Ah, there's a person object in memory. That's great. There's a string here. What is it? Fave num. Let me look inside and see, is there a key called fave num? Because remember how I told you, these are all strings. I mean, we don't put the quotes around it, but that is what's happening under the hood. So it's going to go, is there a key of fave num? Is this it? No. Is this it? No. Is this it? Yes. Return the value there. We would get the number 17. I'm going to show you another way. So here's another way you could do it. Let's say it's not even on the slides. I'm giving you some behind the scenes look. Okay, so let's say we had, I'll do the person.fave snacks after this, but let's say we had, okay, actually, let's do it like this. Let's say we declared a variable in on this line. Let's say we said, I don't know, const, let's say, best num equals the string fave num. So we're going to declare a variable called best num that'll get stored in memory. And here we go, change that to black. Best num is equal to the string fave num. Okay? So let's say we had a line of code here that said person bracket best num. So if you have a bracket with a variable in it with no strings around it, notice how this line has strings or has quotes around it. So we know you're passing in a string. But here, there's no quotes around it. This is what JavaScript will do, is it will go left to the curly bracket. Is there anything in memory called person? Yes, there's an object called person. Great. It will now go inside of the bracket and will recognize, this is written not with numbers, but with letters, but it's not in quotes. So what I'm going to do is I want to look in memory and see, is there anything in memory called best num? Ah, there is. What is its value? A string of fave num. Okay, so the idea is the exact same thing as this line, except now we're using a variable called best num to basically do the exact same thing as this. If we were to console.log person of no string, no quotes, best num, we would also get 17, right? Because best num with no quotes, it'll look inside of memory. What is that? Where is best num? Oh, it's the string fave num. So essentially it's putting fave num where best num is, and then looking inside of person and seeing, is there a key called fave num? Yes, Cesar.
Yeah, I was just wondering, is this what's considered destructuring, possibly?
Nope, this is not destructuring.
Okay, that's where I got confused, because I was thinking about.
Yeah, so destructuring is a different thing that's a little bit out of the context of this lesson, but yes, it is not destructuring.
Gotcha.
Asar. Just heads up, you're muted. Unless you don't have a question anymore. I'll mute you.
Hey, can you hear me?
Yep.
Yeah, I keep on forgetting to unmute.
Oh, everyone always does. No worries.
So the same way we access the value of the key with the variable in the brackets, could we do the same thing with the variable in dot notation?
No. So if you did dot, see, because with dot, you couldn't do, for example, you can't write person dot string name. This isn't allowed in JavaScript. And what we do is with dot notation, right? If we wrote person dot name, it will look in the person when you use dot notation, it will look in that object specifically for that key that comes after the dot. So you can't use a variable to kind of reference another string. Like that's not going to work with dot. With bracket you can, but with dot you cannot.
Gotcha. Thanks.
Okay. Let's move even. Yeah, Tyler.
Yeah, just a quick question.
Yeah.
The constant best num that you declared, was that within the object or outside the object?
Outside the object.
Okay, I just wanted to make sure.
Yep. Okay, so let's go to this next line here. Person dot fave snacks bracket 0. So let's look at that. And also, honestly, I'm going to move this console log. Okay. So if we wanted to, we'll do console here. If we wanted a console log person dot fave snacks. So in this case, what we would have here. Okay, so in this case, it would look to the left of the dot. Is there an object in memory, or is there something in memory called person? Yes, it's an object. Great. Look to the right of the dot. Is there a key called fave snacks? There is indeed a key called fave snacks. What is the value stored at fave snacks? I'll even ask. Let's see. Shukri. What is the value stored at fave snacks? You can. This might even be easier if you look on this line.
So the value of fave snacks is twin snakes and gummy bears.
But specifically, what? Those are inside
Those
of
are
what?
strings. Oh, inside of an array.
Okay, so then let me ask you: if we're trying to see person dot fave snacks bracket 0, what do we think we're going to get returned there?
Twin snakes.
Exactly. So this would console log the string twin. So we can use, thank you, Shukri. So we can use a combination of arrays, objects, bracket notation for arrays, bracket notation for objects, right? Like we can use the combination to get the information that we need. Okay. One sec, I just want to double check. Okay. I also want to discuss with you, how do we add things to an object? How do we add things to an object? But before I do that, Jennifer.
Yeah, so quick question. So we went over how to access the values of the object, but
Yep.
how do I'm confusing myself now. How do we access the keys?
So, okay, good question. So Jennifer's like, well, how do I get the keys? So weirdly, it's actually, there's an easy way to do it, but it's not as intuitive as getting the value. If you wanted to get the keys, you could do, there's a method, or sorry, we're about to go into methods, but there's a function you can use, which you could do. So let's say our object here is called person, right? If you wanted to get the keys, you could say object. Well, firstly, you could console log the whole object to see, but you could also write object.keys of person. This will actually tell you, give you an array with all of the keys. But there's no way that you can, like when you write person.fave snacks, you get the value. But there's no way to just, I'm trying to think of the best wording. There's a little bit of extra steps to find the keys. It's a little bit, if you know the key, it's easy to get the value. If you know the value, you're not going to know the key necessarily.
So there's no way to be like, I want to get the first key.
No, not necessarily like that. I mean, what you can do is something like this will return an array with, so like this, for example, would return an array. If we had person, it would return an array that has like name, company, fave num, etc. So that's one way you could do it, but it is a little bit of extra work to get the keys. Chris?
I was wondering if we wrote console.log and then parentheses person.favesnacks without the bracket, what would populate?
Good
Would
question.
it be both or just null or error?
Yeah, good question. So if I did this, person.favesnacks, like that, right? So Chris, I'll ask you to stay unmuted because I'm going to have you kind of work through this, right? So if we have person.favesnacks, it's going to go look at favesnacks. Well, first, it's going to go look, is there a person? And so Chris, is there a person variable in memory?
Yes.
And what's stored there?
Several objects.
Yep, not several objects.
Sorry, key values.
Value, yes. Inside of a what? You can just say an object.
Okay.
Right? And so it's going to look inside to the right now of that dot. And it's going to look fave snacks. And Chris, is there a key called fave snacks?
Yes.
And it's going to return the value at fave snacks. Chris, what is the value at fave snacks? What is to the right of the colon?
There's 2 twin snacks and gummy bears.
Sure, but more importantly, there are 2 elements, and each of those are a string, right? They're in the quotes, so they're strings. But most importantly, they're also inside of what?
A bracket.
But we don't call it a bracket. What do we call it?
Sorry, I forgot.
An array.
Array.
So if you were to console log person.favesnacks, what you would get would be the value stored there. Simple as that. An array with twin snakes and gummy bears. So that's what you would get.
Okay.
Cool.
Thank you.
All right. Good question. Asar.
You mentioned before that a semicolon, that the comma like separates the key value pairs. What does a semicolon separate within an object?
You mean the colon?
No, the semicolon. Or is the semicolon just like, could you separate other I guess other data types like within the object with the semicolon, or no?
Semicolon. You mean this semicolon right here?
Yeah. Is that ever?
So the semicolon is not a way of separating. So basically JavaScript. So semicolons tell JavaScript, hey, this is the end of this sentence, if you will. This is the end of this specific line. You can move on to the next line. They're optional. A lot of people do them. I use them, but you don't really need to focus too much on the semicolons. But the semicolons don't separate an object from another object, for example. It's just, you could literally write you could have this semicolon not be there and then write another object on the next line.
Gotcha. So only the commas then separate. Okay. Like with inside. Okay.
Yeah. So the commas separate key value pairs inside of an object.
Gotcha.
Commas also separate elements inside of an array. And colons separate keys from values, right? Name, key, colon, value. But semicolons, which is this right here, it's good practice, but you don't need to worry too much about it quite yet.
Cool. Thanks.
Mm-hmm. So the next thing I want to go over with you guys is how do we add information to our object? So I'm going to do this. Okay. So let's say we wanted to add a key of fave city. So how would we do this? If we wanted to add a key of fave city, we write the name of the object that we want to, edit. I'm going to use dot notation. You could use bracket notation and put a string in it. And we'd say fave city. And we say equals whatever we want it to be equal to. So I'll say LA, because I'm gonna do it. So LA, Faith City. This is what would happen. JavaScript would go, okay, is there anything in memory under person? There is. Let me go look to see, is there any key inside of this object that is called Faith City? Is this Faith City? No, 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 no. Great. Then let me add it. And it's truly as simple as that. And you could say person dot let's say fave team. I'll say equals Yankees. Okay. So now it would do the same thing. It would look in. It would say, okay, is there a person object? Yes. Is there a fave team key? No. Let me add it. Now let me ask you this, or rather let me show you this. If I now said after this, person.fave team equals the Dodgers, which is not, I'm still a huge Yankee fan, but let's say it was the Dodgers. Okay, this is what it would do. It would go, is there a person object? Yes. Is there a fave team key? There is indeed. There is indeed. And you know what it would do? It would just overwrite the value stored there with Dodgers. Inside of objects, there's no such thing as like the const concept. You can, every key is a let. You can totally overwrite any value stored at any key. There's no concept of keeping some kind of a key value pair immutable, meaning you can't mutate it. Doesn't exist. Instead of objects, you can absolutely change any value on any key. Yes, Jennifer.
That's exactly what I was going to ask. So if you declare an object with the keyword const, you can still change within the object and add to it, but you...
Yes.
Okay.
So Jennifer is bringing up a good point, which is this. I thought we declared this object with the const keyword. How come you can go in there and totally mess it up? Well, here's the deal. Okay, so you know earlier I said the const means you can't change the value and let means you can. It's actually a little bit more complicated than that. It doesn't just mean that you can change the value and that const means you can't change the value and let means you can. What const means is you can't change, ready for this? You can't change where the variable points to in memory. When you declare an object or you declare any variable, it's saved in memory. And that object, it takes up space in memory. It actually has an address, like a home has an address. Well, when I add things to this object or add things to an array, yeah, imagine it like this. The address stays the same, but I'm changing maybe what's inside of it. I'm changing, the house is the same, it's at the same address, but now I've added a extension on the kitchen, or I put in a new bedroom, or I changed the table. The address is the same. But now if I said, okay, if I said on this line, let's say our line keeps going, person now equals 12, the number 12, JavaScript would not be okay with this, because now we're changing the address. The number 12 is at a different location in memory. Now, you don't need to go too deeply on this, but all you need to take away from this is this idea. Arrays and objects, when you declare an array or an object, it has an address in memory. And you can totally change whatever's inside of that with the const variable. If you say const person equals an object, you can go in and totally manipulate what's inside of that object as much as you want, because you're not changing where that variable is pointing to in memory. Doesn't matter if you add things, it's the same address. Even if you change things inside of that object or that array, it's the same address. But if you now try to change, even if you did this, here's kind of a mind-bending thing. If I said person is equal to an object with all of the exact same key value pairs as this person object, that would also not be okay. Because here's the thing. It's not what's inside of the object that matters. It's the object itself. So whenever you declare a new object, it's a new address in memory. Even if everything inside of it looks exactly the same, to JavaScript, it's a completely different object. And so that's why with const, if you had const, right, const person, you create a new object, this would not be allowed either. Even if I have to have the exact same key value pairs, because that object is a different address in memory. So I can go in and change what's inside of that object or array, because it's still pointing to the same spot in memory. But once I now tell that variable to look elsewhere in memory or save it elsewhere in memory, with a const, it won't do it. Yes, Jennifer.
Okay, sorry, another question.
Oh, good.
Is there any scenario where we would declare an object or an array as with a let keyword, or is it better to use a const?
I would always use const. I mean, the truth is, best practice, you want to try to use const whenever possible, because let is risky, right? Like let means that you could manipulate your data, maybe even by accident. Like const is safe. Right? Const is a way to ensure that we don't maybe by accident change the value of a variable, right? Whereas let means you can totally do whatever you want. I mean, if I declare this object with let, and I said person equals 12 or person equals a new object, JavaScript wouldn't say a thing. It would totally let you reassign it. So you just need to be a little bit, the way I think about const versus let is your default should be const, and use let like knowingly. So for example, if you were in like, let's say an interview and they were like, okay, declare a variable called number and assign it your favorite number. I would probably use let. Why? Because I don't know, they might ask me to reassign the value of number down the line. Like I just don't know. But if I was like actually coding and I know what the point of this variable is going to be and I don't want it ever changing, then I would use const. Like const should be your go-to default. Good question though. All right, sweet. So we've gone over objects. We've gone over key value pairs inside of objects. We've gone over how you access information. We've gone over even how you add information. But there's one more kind of final piece we have here for tonight's talk, guys. And that is, how do you add functions to objects? So let me make this clear. You may have heard this word before. A function stored inside of an object is called a method. If you ever hear the word method, all that means is it's a function inside of an object. There's nothing even more special about it than that. All it means is it's a function stored inside of an object. So we have this object here. Everything else is the same, except now we have this key of greeting, and its value is a function. And here we go. If we did this, global memory, we have our object, and name, Will, company, Codesmith, etc. And then we get greeting. And just like earlier, we store the function definition. So if we look on this second to last line here, if we were to console log person.name, we would get Will, right? Using dot notation, look up inside of this object person, is there a key name? Yes, what's the value? Return that. But notice this last line, it's person.greeting and parentheses. And what do parentheses tell us? It tells us we are running a function. We are invoking a function. And just like with all of our previous functions, guys, we would do the same thing. We would create a new local execution context. We would push it to the call stack. We would execute our code. We would then enter the body of the function. And in this instance, all we would do is console log hello everybody. Now, if I said, for example, from what we've learned earlier, let's say instead I did this. Let's get rid of this line. And let's say instead I did this. Const output equals person dot greet or greeting. So let me ask you, Tyler, based off of what we learned earlier about console log, what would be stored at output in global memory? What would output equal in global memory?
It will equal it'll equal the object's method, which would be the console log of hello, the string of hello everybody.
Right. So console log hello everybody. So our console would say hello everybody, but what would output be? If I were to after this, so for example, if I did this, let's add another line to make it easier to be very clear. If I then console log output, what would this line show in my console?
Hello everybody.
Would it though? Because Tyler, what is the issue? Not issue, but what's the thing about greeting? Right? It has a console log, but what does it not have? What keyword is it lacking?
Oh, return.
Yes. And so if we don't have a return keyword, what will it stay?
It will stay it'll stay undefined.
Undefined. Exactly. So this would show if this was our console, right? If I had a console, we would have hello everybody, and then we would have undefined. But I want you guys to see, and excellent, thank you so much, Tyler. I want you guys to see that there's nothing really different. It's the same process we do over and over because JavaScript is very particular about how it handles these things. And it's because of that particular behavior that we can think like JavaScript does. We can literally draw this out. We can whiteboard this. This is what we've been doing for the last 3 hours, right? Is that we can think the way JavaScript does. And because of that, we can actually advance through JavaScript. We can encounter JavaScript code, functions, methods we've never seen before, and know exactly how JavaScript will work with them. And that honestly makes the learning process a little bit more smooth because we can think the same way our machine does. All right, any questions before we wrap up? Yes, Ronald.
Before on the earlier slide, you did a person dot fave, and then you added that team.
Yes.
And then when you added that new team, it replaced the existing team for the value. Can you make it so it like adds to that one, like another element?
Totally. So as I said before, objects don't have any concept. There's no way you can add to another one. Now, what you could do, here's what you could do. Let's do this. I'm going to actually, Ronald, let me ask you something. If let's get rid of all these. If I instead wanted to have my fave team, and I had a couple fave teams, and I want to put a couple things, what are some things we've used today that help store multiple pieces of information?
We'd have to make that into an array.
Exactly.
There's 3 teams in there or whatever.
Exactly. So we could say person dot. So let me actually just get rid of this. Let's say we didn't even get to these lines. We could do something like this. We could say, person dot fave team equals an array. And then we could either directly put them in here, right? We could do something like, an array of Yankees and Dodgers. Or say we didn't know what our fave team was quite yet. We could do an empty array. And then for those that don't know how to add things to an array, we use the push method. It's the same concept as our call stack. So you could say person.faveTeam.push Yankees, Dodgers. And that would push those values into that array. Good question.
Thank you.
Yeah. All right, Ignacio. Oh, you're muted, just heads up.
Right, can you hear me now?
Yep.
Right, thank you. So what I wanted to know is how can we iterate through the key pair values of an object, of any object?
So good question. So there are a couple ways you could do it, but the best way to do it would probably be what's called a for-in loop. So some of you may know what for loops are. If you don't know what for loops are, our intro to JavaScript variables, control flow, and looping goes over for loops. You could do what's called a for-in loop. So I'm going to give you a little taste of it, but I'm going to ask that you kind of maybe go off into your own to do a little bit more research because I don't want to confuse anyone. But let's say we have our person object, right? We see that. We have our person object. If I wanted to iterate means loop through this object, I could do something like this. For let key in person. And let's say we said console.log key. Whoops. Key. So what this does, Ignacio, is actually I'll even color coordinate this a little differently. Let me do this a little differently. So whatever argument you put here, that's the name of the object you want to iterate through. Whatever argument you put here, that's the name of what you want to basically label every single key. So if I console log key, we would get in our console log name, company, fave num, has red hair, fave snacks. If I instead, I could call this anything. I mean, I could call this banana. And if I console log banana here, it would console log name, company, fave num, has red hair, fave snacks. If I wanted to console log the values, I could do console log person key. And this would console log values. Now notice I have to put a bracket and I have to put it in no string because what key is at that moment is a variable referencing the string name, the string company, the string fave num, etc. So this is how you can iterate through an object.
Right.
Yep. Cool. Any other questions? I know that might have been a little bit confusing, but don't worry about it if you didn't quite get that. Ronald.
Just one more. Like I don't. You can go over it, but like for the while loop. You know how like for the for loop, for let one that you just did right now.
Yeah.
With the while, I see like sometimes I see some examples like while, and then it has the parentheses, and then I have like let's say less than a number or something, and then but usually outside of it, it'll have like const I equals whatever, or it'll declare the variable outside of it. Can you do like while parentheses and then declare it in there and then do the like whatever equation?
So you don't declare a variable inside of a while loop, right? The while loop is just a condition. It's just checking every single time it's checking, is this condition true? If the condition's true, enter the while loop. Get to the bottom of the while loop, get to the top of the while loop again, check, is this condition true? As long as the condition is true, then it will operate the while loop. But you would never declare a variable inside a while loop. Just for people that aren't sure what a while loop is. Okay. So like this. I don't want to go too much into it because again, like we have a whole nother lecture kind of on this concept, but basically like, let's say we had, let I equal 10. Okay. And we said, while I is greater than 4, I want you to console.log I and then decrement I by 1. That's what that means. Take I and now subtract it by 1. So it would go like this. Okay, while I is greater than 4. So while this is true. So Ronald, let me ask you, is I greater than 4?
Yes.
Yes. So if this was our console, let's say on the side here, for some reason, we would get 10. Then it would hit this line right here, and it would make I 9. Now, Ronald, is 9 greater than 4?
Yes.
Yes. And then it would hit this line, and it would decrement it to 8. Is 8 greater than 4? Right? Boom. 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 So Ronald, is 4 greater than 4?
No.
No. So now we would move on to whatever code is over here under this while loop. Cool?
Mm-hmm.
Okay. Any other questions? Alrighty, so we're going to do a little quick recap here. So we went over functions. Honestly, we did go over object looping. Normally, I actually don't go over object looping, but we did do it today. So we have functions. We went over execution context. We went over objects. We went over object looping. Guys, the things you have learned tonight are huge leaps forward in your understanding of JavaScript. I mean, these are, I would say, even bigger than like kind of the building blocks. We're kind of getting even to the more meatier aspects of JavaScript. So you should be really proud of yourself on that. So what's next? Should you be interested, we have our beginner workshops. Remember, this is, in my opinion, kind of the 3rd out of 3 intro to JavaScript classes. There's HTML and CSS, variables, control flow and looping, then objects, functions, and the execution context, which again, kind of how the, no problem if you didn't, but that is kind of the order of basic to more advanced. Then there's the JavaScript hard parts, which are the more advanced concepts off of that. We also have JavaScript for beginners, CS Prep, but we also have CSX, our online learning platform, as well as our fast track application. So thank you so much for spending your evenings to afternoons with me learning about JavaScript. I'm so happy you guys got to hang out. I hope you learned a couple things today. Just keep coming. Keep coming. Get to know your crew, get to know everyone here. You know, just keep going down the path of learning. Alrighty, guys. Hope you learned a lot. I will see you guys hopefully soon. Otherwise, have a wonderful night.